Hi, today we learn about our physics first lesson, reflection of light at curved surfaces. So I'm not going to describe how the concave, convex lenses and how the reflection, where the image forms, everything. So today we'll discuss only on focus on problems, how to solve the problems. So before getting into that one, a small introduction, just to understand what our curriculum, like curriculum in the sense, uh, what exactly this chapter explaining. So this curved surfaces is like a very vast chapter, so where we discuss as many types of curved surfaces are there. So out of that we'll be he's just, or to say, the syllabus is introducing you to this light concept. So he won't focus on many things, so many different shapes. So he is introducing with concave and convex, so only two types of things, and the two convex, so only for two types. So in these two types also, this is concave lens, so and this is convex lens. So only two types of lenses, and that too a coated surface on the inner side, so that means reflection only. So we will discuss these two shapes and what exactly he is talking about reflection. So if we look at this words carefully, so in all my lessons I'll focus on what the chapter name and the words. These are very important things that we have to focus. So reflection, light, curved. So reflection, he's not talking about the in light. There are two concepts: reflection, refraction. Reflection and refraction. Flexion, fraction. So reflection is you already know that reflection is like uh, what is that? When something, okay, when we throw a ball at a wall, okay, we threw a ball at a wall. So what happens? The ball comes back. That is called reflection. So when something passes through the things, like okay, there is a small paper kind of a thing. If you hit with a stone, what happens? It will pass through that one. That is called refraction. So even the light also the same thing. Sometimes when light hits few surfaces, it won't be go on the other side, like our wall. So inside our room, if we turn on a bulb, so what happens? It won't, the next room won't get the light. So because walls would stop the light, isn't it? So that is totally, the light will be inside the room only. Whereas refraction, if you make the same room with all the walls with glasses, what happens? So like our windows, when somebody turn on a light in a home, if there is a window is made of glass, that is transparent. So neighbor can see, oh, there is a light. People might be watching something or something they are doing. They can easily know that one because light refracted. This our TV light or something light, it passes through that, through the window. Window means, I mean, window made of glass I'm talking about, not window made of wood. Wood block the light. So here light is refracted through the glass, whereas wall, not wall. So if the same window, if you coat, like okay, with some clay, so take some clay and apply it on the same glass of this is a window made of glass. If you coat this with the clay or something very thin, very, what to say, that doesn't pass light through it. If you do that coating on the other side, okay, leave it like a mirror. So if you coat on the other side, then the light will be reflected. So if light goes like this, light will be reflected back. So that's what it all. So in physics, how we denote the way we depict that one is with the lines like this. These lines means, okay, you can think anything, so it would be coated with clay or something. That's what it means. So light can't pass through that coating, so it will be totally reflected, no pass through, completely reflected. This is called reflection. So like a ball, how it will be reflected, so the same way light also will be reflected. That is called reflection. So next one is reflection of what? Reflection of ball? No, it is reflection of light. That's what we are going to study. And what kind of surfaces we are talking about? Curved surfaces. We know that this is a smooth surface, straight one, whereas we are talking about curved surfaces. So how the light will be reflected in these curved surfaces? That is what we are learning. So if the light falls like this, what happens? If the light falls like this, what happens? If the light falls straight, what happens? This is what we are studying. So if this falls here, it will be reflected with the same angle. So that angle of reflection is so angle of incidence is angle of reflection. So those things we will study. So it's all about reflection of light at curved surfaces. Only these things we study. Inside the curved surfaces also there are many different types of surfaces. We are not going to study all of them. We study only concave and convex lenses with coated surfaces. Coating means, okay, this side we applied clay. Think like we applied clay. So here also we applied clay. So it's like a cave. So this is how I remember all the time. So it looks like a cave. So whereas this one is, so inside it is coated. So this is concave means this will be convex. That's how I remember the things. So here light falls like this and reflected here. So you might have studied already. So reflection, incidence, reflection, incidence, reflection. So only we study these two. Yeah, let's come to the problems. Okay, before getting into the problems, we understand the sign of convention. So without understanding the sign of convention, you don't get the problems correct. So first understand the concepts, like, okay, how we have to measure distances. You might be confusing, like sometimes he is taking the focal length negative, sometimes he takes it positive. What exactly it is, we are going to see it now. Okay. Yeah. So in this one we always see like radius of curvature. Radius of curvature. So, and center of the curvature. Radius of curvature and center of the curvature. So what are these? What is curvature? So we are talking about curved surfaces as we discussed. So when there is a curved surface like this, so coated in outside, it is a concave because it's like a cave. So what exactly he means, like radius of curvature? This small we are taking, actually this is a big glass. In this one we cut a small piece. We cut only this piece of the big circular, not circular, spherical. So you know the sphere, right? The spherical glass, we take a small piece. It is not even half, very small piece. We take it, and in this one we check the reflections and refractions. Why we take only small piece? That is good enough to, like, okay, making a telescope or a microscope, everything, like, okay, it's all, this is good enough. We try to make our light fall on this particular lens and we magnify or minify those things. So we need only the small piece, but even the small piece, it will be having a radius. So this is the radius, and this is called curvature. So the radius of the small piece is this much. So what it means is, with this small piece, if you make a big sphere, then what is the radius? That is called the radius of curvature. Radius of the small piece curvature and center of the curvature. If this small curvature piece, if you make a big circular or a spherical glass, where would be the center? That is called, we call center of the curvature. So we always take a small lens. This is good enough to make a telescope. We don't make a entire big sphere. So only these things are good enough. So this is radius of this small curvature. That means if this small upper curvature, if you make a big spherical thing, where would be the center? That is called center of the curvature. And if you make this big spherical, what would be the radius? That is called radius of the curvature. So, and another important fact is, there will be a focal point where all, okay, we already discussed that, okay, so when all the parallel lights will be what to say, intersecting at focal. So we denote that as F, and it will be exactly half of the radius. This is R by 2, this is R by 2. So this focal is the center point between the center and the any point on the curvature. So it is exactly half, it will be. So yeah, this is diameter. Diameter's half is radius. Radius half is where the focal point will be. So these are all important things, and this is called pole P. So yeah, I think these are the important points we need to remember. This is the curvature, and this is the center of the curvature if you make a bigger one, and exactly at half of the distance where focal point will be there, and how the focal point, it will be half of the radius. And we also denote this focal distance is F. Even I too don't know why we go with always focus. We can also say that half of the radius also is the same, isn't it? So focal and half of the radius are same. So that is F equal to radius of curvature divided by 2. So this is another thing that you need to remember. Okay, then we also know that U equal to distance of an object from pole. V is distance of an image from pole. Not any image of this object. So we know the U, we know the V, we know the what they mean. Distance of an object. So whether it's a candle or a pencil or anything, that is called object. So we calculate from the pole. This is our pole. So if the object is here, so like a candle, so distance of an object from pole. This is my pole, this is my object. The distance is called U. V. If the image formed here, then distance from pole, from here, if the image forms like this, inverted image, then from here to here is called V. Let me use this one. From here to here is U. This is V. Okay. So the formula, you know, that is 1 by f equal to 1 by u plus 1 by v. Easy to remember. Yeah, remember this one. So sometimes f is negative, u is negative, v is negative. We will get into that topic shortly. Yeah. So now we are going to discuss about the signs. So how, when we have to take positives, when we have to take negatives. So before to say, you already know all these points what we are doing here. So here P is pole, F is focal point, this is the image, and this is center, and this is where the object. And we also previously discussed, this is the focal length, that is F, and this is V, the distance of an image from the pole, and this is distance of an object from the pole, U. Okay, so this is sign convention. So few rules to remember. So what are the rules? Always we have to measure distances from pole. So we have to take, if they ask, okay, what is the distance from distance of an object from pole? So everything, distance of object, everything, all the things we have to measure from this point only. So think that you are here and walking towards the object to measure it. Okay? And always distances from the pole, and so you have to, so when there is a object light always travels from the object, sorry, it goes in a straight line. Light doesn't go, it always go in a straight line. Okay, so light travels from the object towards the mirror. It will travel from object to the mirror. We take this direction as positive direction. So people get confused, like, okay, you might have plotted so many graphs like this. So always these are positive numbers. Hey, here we are doing something different, right? So we are taking the light direction is positive. So don't get confused with your graphs. So sometimes it will be so confusing, like, hey, this side is positive, this side is negative. No, light direction, measuring in the direction of light is called positive. That's what we do in these problems. That is what sign convention is always tells. Okay, so we consider this direction is positive, anything measuring in this one. And also heights above the this one principal axis, so that is called positive. So this is, you are measuring from here to go up, going up is positive. Measuring from this axis, principal axis, to in this direction is down is negative. Remember this one. So what are the sign convention rules? Always measure distances from pole and consider the light coming from the object is positive, and heights above this axis going up is called positive, down we have to take it as negative. Okay, if you remember all these rules, so let's see. Our problems now. Here, so this is your example problem. So the solution is already given in your textbook. So the why I'm explaining the same question is just to make you feel comfortable with the directions. Okay, so if you look at this problem, he mentioned that an object is placed 4 centimeters in size. That means he is giving, okay, let's take that object as candle here. So what he is trying to explain is the height of this is 4 centimeters. and it is placed at a distance 25 centimeters from a concave mirror. So this is our concave mirror, and at what distance it is placed? 25. So this is 25. Here u is 25 centimeters. Of focal length 15 centimeters. So this is focal length 15 centimeters. At what distance an image is formed? We know, first we can write the formula. So I don't know whether the place is sufficient or not. So first I'll make it into half. 1 by f equal to 1 by u plus 1 by v. We know this formula. So it's all about not placing the numbers. It's all about, if this question is given for 2 marks or 4 marks, he's not testing your mathematics skills on this one. We know f is f value is, focal length is 15 centimeters. Good. And u is placed at 25 centimeters. Good. And he is asking v. It is easy, right? We know f, we know u, we can find v. All depends on the convention. That is the tricky part. Let's handle the tricky part. F equal to 15 centimeters. Well, is it positive or negative? Okay, let's see. So, what our sign convention always says? Measure distances from pole. So, focal length. Focal point is here. I have to measure from the pole. I think I'll pretend like I'm here and I have to measure from the pole. I will walk like this slowly to measure the focal length. I'll walk in this direction. So what our sign convention says? If the direction of the light is positive, I am going opposite. So direction of light is like this. I am moving in the opposite direction of it. That means it is negative. Because I have to measure it from the pole. Initially I have to stand here and walk towards the focal point. So definitely I am walking in the opposite direction of the light. So it is negative. So, and let's take the distance of the object from pole, that is u. Is it positive or negative? Let's see. So I have to start from here because I have to measure all the distances from pole. I am stressing this point, from pole. So you have to be there and walk towards the object. How you walk? You walk in the same direction until you reach the object. So you are walking in this direction. The direction of light is in this direction. So these two are opposite. So you take a negative. Okay. So now we got the negatives or positives. Now let's put the values. So I'm just replacing and moving the numbers here and there, and 5 2s, 5 3s. So 1 by v is minus 2 by 75. V equal to minus 75 by 2. So all are in centimeters. So this is centimeters, equal to minus 37.5 centimeters. So That's the value. So again we got negative number minus 37.5 centimeters. How we have to pretend? So what it means is 37.5, all the distances what you have to do, measure it from the pole. So you are here. Now we have to count up to minus 37.5, right? So that means you have to keep walking. And this is the what? 25 centimeters, right? Until this point, we have to walk up to 37.5. We have to keep walking, keep walking. Why I have to walk in this direction? Why can't I walk in this direction? Because it is negative. I have to go opposite to the direction of light. Direction of his light is this one. This is positive. To make it negative, I have to walk in the opposite direction of the direction of light. So I have to walk in this direction. So I have to walk. At 25 centimeters, I made this one. But still it is 37.5. I have to keep walking. So I have to walk until 37.5. Think this one. Here the image is formed. So why I took this image? Initially I can take any distance. But finally the result will come. Image is formed here. That's the objective of this one. Sign notation. So once you understand the sign notation, you can do anything. So that's all about the sign notations. So you know, so height, why he gave the height 4 centimeters. We didn't use this height anywhere. So I wrote the half of the problem. Another half of the problem is magnification. So I will explain what is the how much magnified the image is. Okay. Yeah. So one thing if you observe, so the way image forms, that is way, right? It doesn't depend on the height of the object. So height is 4 centimeters or 40 centimeters. So the image formation doesn't change. So it only depends on the focal length and also where the object is placed. It doesn't depend on how tall the object is. So you need to remember that one. Then why he gave the 4 centimeters? Just to, but this height, image height depends on the height of the object. If the height is bigger, it might be bigger or smaller or something. So that time height is important. Only for calculating the magnification related things. So that's all about, that's where we need the height of the object. So how we measure magnification? Magnification equal to height of image divided by height of object. Okay. So, and it is always, we put negative because image is formed. So we already learned going up is positive, heights. So this is positive. Image is formed downwards. That's why we take it negative. Okay. Yeah. So I know that okay, the images are formed negative, but if we remove this one, so this is actually the formula for the magnification, height of image divided by height of the object. So how it will be? So from the formulas, like okay, they say like hi is the height of the image and ho is the height of the object. So hi by ho is equal to minus v by u. This is the formula, and we derived this one already. So if we do this one, height of the image, or to say, we need to determine height of the image and height of the object. It is 4, HO equal to 4. Always leave the gap in front of 4 to put a sign. We are going from the principal axis upwards, so it is positive. So HI by 4 equal to V. How much we derived? So we already got it in the previous one. It is minus 30, this one. And U. What is the U value? It is 25 centimeters. How it was? We are going in the opposite direction of the light, so it is negative. So if we replace all these things in this formula, minus of minus 37.5 centimeters by U is minus 25 centimeters, and this is 4 centimeters. Cancel. HI equal to minus of minus is positive, 37.4, sorry, 5 multiplied by 4 and minus 25 centimeters. So which is equivalent to 150 minus by divided by 25 centimeters. 6 centimeters, minus 6 centimeters. Since we got it negative, what it means? So this is our principal axis. So we already know it will be formed at a 37.5 negative, that means in this direction. And what is the height of it? 6 centimeters. The original candle light is 4 centimeters, but this is from main axis. We have to go down because it is negative, and this is 6 centimeters. That's how we saw how to solve the problem.